Hey guys, so real quick update on Old Red. So Old Red made 463 horsepower to the rear wheels. I was shooting for 460, so I'm pretty happy about it. So I've been asked a few times about how do I qualify my flow bench. Okay, so I'm using a 3-inch orifice. So the first thing you're going to want to do is put a 3-inch orifice up here. Okay, make sure that where your pressure tap is feeding from, that you're as far away as you can without going over the wall, so that this area is still dead and you don't have too much flow passing it, messing up your differential pressure measurement. Okay, next thing you're going to do, if you're using a Testo 510i, is you're going to go to volume flow for pitot tube. Okay, I think you can see that. And then you're going to set in whatever your diameter is, what the temperature is and atmospheric pressure is for right where you're doing it. Alright, turn on your Testo, and then you're going to need one of these, otherwise you're not going to be able to do this. So I've done this in other videos, but this is a pitot tube. Okay, I'm not going to go into how this works on this video. I have my very first video will tell you all about them and how they work. Alright, so what I'm going to do is I'm going to turn the bench on. I'm going to get it up to 9 inches of water. Okay, and I should be around 375 CFM. Okay, so the way you use these things, I've explained it before, is I'm going to do a time traverse for 10 seconds, up, down, down. I'm going to stop it. And whatever the delta P is, I'm going to record it. And then I'm going to do the same thing 90 degrees out. Okay? And then I'm going to take those two numbers, average them together, and that'll give me my CFM that it's flowing. Okay? So first thing I'm going to do, and I should see that's just qualifying my bench. Okay, so I'm going to do this rough just from the video's sake, but I've got all my nozzles kind of where my bleed valve's about where it should be. So we're going to turn it on. It'll get a little loud, so you may want to turn down your volume. Okay, so 376.04, okay, is average. 375.56 is what is the average started off with whenever I first built this bench. Now again, all I did was I did 2 traverses per 90 degrees. In order to do this accurately, I do 10 times on each 90 degree for a total of 20 samples, and I average all of them together to get a more accurate number. But again, just with 2 quick traverses on each 90 degree offset, 376.04, 375.56, and that's less than a CFM. So I would say that that's very accurate. So again, use the same size orifice plate, okay? Test pressure, okay? So at 9 inches of water, I flow 376.04, and that's the number that you're gonna use when you flow your heads. You're gonna compare whatever the delta P is across the orifice, the square root of that number, divided by your test pressure of 9 inches of water, and then multiply that by this CFM. That gives you a percentage of flow, and then multiply that by the CFM, gets you your total flow, okay? At that lift value. Let me clarify one more thing. If you want to flow more than 350 CFM, you increase the test pressure. In order to increase the test pressure, you have to increase how many motors you're running. It takes a lot of power to pull enough air to move that much, okay? So for example, after that test, I just to figure out what my bench, someone on here asked me they want to flow something to 500 CFM. Well, if you want to flow 500 CFM, on my bench, I need to turn a couple more motors on, and at 16.5 inches of water, with a 3-inch orifice, 16.5 inches of water, it flows 500 CFM flat. So what I would do is the same thing I would do with that 375 number that we came up with. I would say, okay, my bench flows 500 CFM at 16.5 inches of water. So you would go flow your heads, whatever they are, up to 28 inches of water, and you would take the differential pressure across the orifice, okay, square root that number divided by the 16.5 inches of water test pressure. For my bench, again, you need to qualify your own bench and make sure. It might be, you know, plus or minus a little bit, depending on how your sharp edge orifice is cut. And whatever, if somebody tells you that it flows 350 CFM at 9 inches of water, don't take them for their word. Mine was supposed to be the same thing, and again, I qualified it as soon as I got here, and it flowed 375.56 after 10 traverses in each 90 degree offset at 9.01 inches of water. Okay, so, you know, it's going to be close, but that's going to mess up your CFM readings if you say it flows 350 when it flows 375, so you'd be artificially messing up your CFMs that you're actually seeing. So anyway, so you would do the same thing, okay? So whatever the differential pressure across the orifice is, square root of that number divided by your test pressure. In this case, it'd be 16.5 inches of water, or 16.25, whatever it was, and multiply that by 500, okay? And that would give you your CFM, okay? So you qualify your benches before you're going to do a flow test. Always qualify your bench. It makes sure you don't have anything funky going on. Your tubes aren't leaking. You know, if I don't have the orifice plate in the right spot, it can mess up your test. So just make sure just make sure your bench is good. Make sure you check your orifice plate and make sure everything's sealed up good, and get your CFM reading, and then go flow your heads and have fun. Alright, if you got any more questions, let me know. Hopefully that answers the questions I've been given. Alright, see ya.